So I have a local extreme is marked as explored left to right if we try to go left to right, but it wasn't possible. That means that I need to have a pointer to the last local extreme. So again, I have in my notes, see description below the video. A local extreme is marked as explored left right if we tried to go left right, but it wasn't possible. And I think that that description comes from historgram.cxx. But I think the correct translation for that is that we ran out of energy. I'm not even handling that at all yet. So if maybe update is called and it returns false. That would be here. Hotel. Yeah, okay. What the hell was the name? Was damn it. Okay, point 2. We find a new local extreme by exploring in the direction left right from a previous extreme, and it is adjacent. There is no extreme in between. That the previous extreme is marked as explored in that direction. And I forgot again how I called it. Oh yeah, handle local extreme jump. It says, 2, we find a new, see the description of the video, whatever. 2, we find a new local extreme. Well, if that happens, then we call this. No. Then we call handle local extreme. Then we call this. And this happens after exploring in direction H direction. From a previous extreme. And it is adjacent. And the previous extreme is marked as explored in the direction. Okay, that means that as soon as I'm certain that we found it, I guess I'll just wait until we have the warning starts again. Until set local extreme is called, so it would be here. So that will be that one. Just one more point. If you already saw a minimum going from adjacent local extreme to the next, then also mark the newly found extreme as explored in the opposite direction. Explored in the opposite direction and towards the already seen extreme. So if saw minimum maybe I should do that in here, but I can only do that if I can't do that in here. No. So if saw minimum, then what? Mark the newly found extreme as explored in the opposite direction. Means two things. You must initialize saw minimum with false. And it is. And you must reset to false. If we do something else, then continue searching in the same direction. I guess that's only when we jump. So that would be a local extreme jump then. There's also going to be another case, but I'll just try to remember it. So I have to set this thing to false if we jump to, that was handle, local, extreme jump, I think, yes. that is initiated from here. So I'm going to set now wait a minute. If we jump to the best minimum, then definitely saw a minimum already. So rather I should set it to true. And then from there we might jump further, but no. And then do I also set visited when jumping? Now, if we recursively call this, so minimum is already set to true. So this is the same as you already saw a minimum. Going from adjacent local extreme to the next, mark the newly found extreme as explored in the opposite direction. So I should do here neighbor explored Well, I hope that was all. So now we should have a clean exit. Undeclared saw minimum. Great. Followed existed. Oh, histogram. Yeah, duh. So I have to add it to algorithm. Damn it. Poo-poo. This is new debug output. Last extreme is now set to 1, as in 1, 2 cubic. $316. Yeah, duh. Oh, okay. It's actually correct. I'm not happy that both that one and that one are humongous steps, as in larger than 10 times the scale. What is the scale here? 2. It shouldn't, no. It should not want to go further than 20 at a time. It just doesn't make much sense. So these things should have been rejected. Okay, the test suite is overriding it anyway. It's just forcing it here. There we go there. Then we found another local extreme. Oops. What did that do? And the local extreme set last extreme cubic to 11. That is at the bottom there. Setting the left neighbor of 11 to 1, 2. Setting left neighbor of. Okay, that's not good. I think this should have been double quote. Yeah. Because I don't have debug output for when I set something as explored. Let's just add that first. Oh, totally should be printed. Okay, so nothing was explored yet because we didn't find a minimum yet. So remake. So now sol minimum is set to true because we found that one. And then if you continue and find this one, it should do something because then we saw this minimum and that one is adjacent. Yeah. Explored right on 17. That's not correct. Should have said explored left. Which rule is that? The rule is if we already saw a minimum, yep, going from adjacent local extreme to the next, like from here to the next one, then also mark the newly found extreme as explored in the opposite direction. That means towards the already seen extreme. Now we're going from here to there. That is, we're going to the right, so it should have been marked as explored to the left. And this is the level of a local extreme, which should not go between brackets, between double quotes. So this call to explored came from where? No. One of many. Just wait a minute. Left, left. So each direction is in the direction of that neighbor. And then the neighbor is marked, it's explored in the opposite direction. Yeah, this should be good. And this must be the one. Huh? Yeah, it should be opposite. So we're going to right and we mark it as explore to the left because we already saw a minimum. Yeah. Okay, and then you have comments here, or commented out. It's probably, well, this is from historgram.cxx. So this is what I'm now implementing. The last extreme cubic local extreme get extreme type is a minimum. Then we saw a minimum. This is an update of the best minimum, of the best cubic. Yeah, the best minimum, which I already do. We definitely handled this part. Oh, I didn't handle this. Oh, I totally did, sorry. Totally did. This can be removed. And this one is the absolute value. The last step is 1. That means that it's adjacent. Then mark the last one as explored. Yep, I did that too. If the current extreme is a maximum, then it can be marked as having been explored to the opposite direction. In that case, the previous extreme is a minimum. Or if the current extreme is a minimum, we came from another minimum, step size, steps of 1. Then mark it as having been explored, so minimum. So we just did this. Just delete it and oh. Yep. Okay, entering explored left 17. So 17 has been explored to the left. We will not do that again. It's the only thing that ever happened so far. And now here we have explored explored. Well, we have a lot, denk ik. Yes, I think. No, only 2. Explored left 6. That was this one. And it is marked as being explored left, which is because we saw this minimum. So this minimum is adjacent to that one, therefore we have explored to the left. It's not marked as explored to the right, because that's correct, we did not explore to the right. And 1, yeah, this one is explored to the right, that way, because this minimum is adjacent to it. Now you can argue, I mean, that this should already have been marked before. Namely, at the moment we find this one, we have a neighbor on that side. Is that not a rule that we have? We find a new local extreme by exploring in the direction right from a previous extreme, and it is adjacent. There's no extreme in between. Then the previous extreme is marked as explored in that direction. Yep, 2 should have been marked as explored in the direction right at the moment that this one is found. Surely that didn't happen. Did not happen. So it's detected as local extreme. And then nothing. Yeah, wait a minute, this is done. So I think left neighbor of 11 to 1. Do we even know that the neighbor is there? The right neighbor of 1 to 11. But it's not marked as being explored. Next extreme type is toggle to maximum. I don't know, somewhere in handle local extreme, I guess. Let's just try to find it. Hi Mitchell, by the way. Yeah, I wasn't looking at chat as usual. And Clement Terran. So we enter here and then the state is not extra sample. does not have an opposite extreme. Mark it as a local extreme. We find the neighbor in the direction where we came from, and we mark it as explored, except that we don't. Weird, yes, totally weird. You have to debug this because it should have happened. So let's go to entering that function. And then blah, 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 blah. You just entered local extreme. Handle local extreme. Set local extreme. Neighbor, each direction. Maybe the neighbor was unmarked. That is totally possible, of course. Should be right, huh? Yep. Step or yeah. To the left neighbor, no. Yeah, that looks like end. It's just nonsense. Okay, what is happening? Frame, we didn't execute it. Now we did execute it. Yeah, it's end. So left neighbor was not initialized yet. We did not set left neighbor. No, why not? Maybe I'm just too early in the code. Totally too early, probably. Yeah, I'm too early. I mean, we just discovered that this is a local extreme. I think the neighbor is set like way down. Yeah. Set left neighbor. I think I should move this code up actually. That works. Last extreme cubic must be set. We do that super early. Just hit start and then see, no, this is not local extreme, extreme type. It's nothing to do with a cubic, with a polynomial fitting. Already know all that. Not sure about this one. Depends on if I still use the next extreme type. Now we are really starting to look for fitting. So I think I can move this, maybe even that one. All the way up to till, let's see. So that must be put before this point. There is no return, I think. Let's put it there before I lose it. Shift 2, 3, 4, J. And then look for a return. Well, the earlier we abort, the better, I would say. So if we abort there, then we're not bothering with doing the neighbor stuff. Probably should do that. This is not necessarily necessary, and this is not necessary either, I think. And this is, however, necessary. The neighbor must be marked. So I don't want to return before we did this. I might as well put it all the way down here. Which is then this one. Keep track of the best minimum so far. So let's move that down. Yeah. So I could put it here. Yeah. I'll put it here. Bit random. So then the return is on there, or is there another return? No, there's a comment. Lambda return true. That's asking for the new sample, so I think we should already know. We didn't do this yet. Asking for a new sample without changing the extreme type. Yeah, we re-enter this, so I don't want to do this twice. So this must be done beyond that point. In fact, I don't want to do anything twice. I don't know. It's really. Let's look up to where this was last used. Okay, there, yeah. So I have the feeling that I could do it here as well. This block is only executed once, even upon re-entry, because the second one, then the state is extra sample, so I do this. So I would not toggle next extreme type twice, but we would do the extra sample while next extreme type is different. But that really doesn't matter, I think. So yeah, could move this up. I'm not going to move it up though. I was just going to say if it compiles then it works, but no. You don't have extreme W anymore. Really? Okay, I'll just call this directly then there. Deep output. Ship it. Okay, here we go again. Bing. And this time it said, yay, entering explored right 1. So this one is now explored to the right, which is true, because we found the minimum. Yeah. Let's continue. So then, that moment we say, oh, we even say 2 things now. What an improvement. Allowing the explore to the right. No, it's not. Shit. 17 is explored to the left. This is not explored to the right. Because the solve minimum doesn't count for itself. Rather, we have two types of solve minimums. I think. Or no. What went wrong here? Explored right. Now we get in 17 and then we look to the neighbor and we mark this as explored. This is bullshit because 17 is not the minimum. Nor did we see. So we also didn't see a minimum. That is, at the moment that this minimum is found, then that one must be marked. That might still happen, hopefully. I'll just have to debug this again. From the last handled local extreme, which is probably just that one. 1140. Okay, we found 17. This is 17. Then we find neighbors. Set left neighbor. Setting left neighbor of 17 to 11. Setting right neighbor of 11 to 17. The other direction, there is not much in the other direction, but okay. Neighbor. So what is this? H direction is still right. There is no neighbor in the direction right. No, wait a minute. Opposite. If it is right, then we get the left neighbor. Yeah. We get a neighbor anyway, but you get this neighbor here. So the neighbor exists. Mark it as explored. Yeah, that's not correct. That is not correct. Or is it? I mean, it's like the comment says, right? It doesn't say that it must be a minimum. It just says as soon as we find an adjacent extreme, then it is explored in that direction immediately. This was so non-intuitive that I had to write that a separate program to brute force the rules. And then I didn't really write down the rules, I just had a program. And then a month later or 2 months later, I looked again at that program, which by then I completely forgot how it worked, and deduced the rules from it. So it's all very fuzzy. It's like a quantum programming. It feels correct. Maybe the best thing to do is look at the histogram again for this very specific thing, and then hopefully understand what it is doing. Explored is called from mark explored. Is explored, is explored, is explored, mark explored, mark explored, mark explored. Yeah. So only mark explored does it. And what it does is it just marks it as explored in that direction. And then mark explored just prints a deep output. So every W here is a local extreme, so we just mark this local extreme as explored in H direction. Hello, LD. So this is the rule: if it was not possible to go in that direction, mark it in that direction. We did that. Let's start at the top. That's the first one. Then here we have another one. In total I found 3 rules, so this should be the only 2 left. This is the third one, and yes, to the top. Okay, so these are then the two. So if we enter handle local extreme and it is an adjacent local extreme, then mark the previous one as explored. Well, this really doesn't care if it is a maximum or a minimum. So yeah, seems correct then. So we mark it regardless, and then only if we saw a minimum, we mark the current one as explored in the opposite direction. Try to remember that. We mark the neighbor regardless and the current one in the opposite direction if we saw a minimum. That should correspond to what I'm doing here. So those are these two. So yeah, the neighbor is marked regardless. And if you saw a minimum, then the current one is explored in the opposite. I think it's corresponding to our brute force program that worked. Therefore, we can continue investigating how the program is running. So again, 1 is explored to the right. "11", this one, is explored to the right, and 17 is explored to the left. And finding this one leads to 17 is explored to the right, because it's just an adjacent thing. And 6 is explored to the left. This one, yep. So they are each other neighbor. Then you have to do this, I guess. And then also 1 is explored to the right. This one is explored to the right. But it already was. So I'm doing that twice now. Not too bad, but okay. The reason that we do it again is because I'm jumping back here, and then from here I'm jumping there. So I was like, hey, this one is adjacent to that one now. Yeah. And then we go down to minus infinity until we abort. No, it says 17, so explore to the left. What? It was already. Why would I do this? So we went so far to the left that we were at minus 7,785.13. And then we gave up because you got not a number, and then we jumped back to the best minimum so far, that is here, and then we should have aborted immediately, because this one was explored to the left and to the right. Certain of it. 11. 11, no, there's 1. 11 to the right. Gotta be kidding me. It's not explored to the left. Why would this one not be explored to the left? Oh, right. Yeah, because we did not find a minimum on this side. Well, it goes to minus infinity, but I'm not counting that as a minimum. So that's funny. So we go here, we jump back, and then we want to find the maximum, which already exists, and then we want to find the minimum, which fails, because it goes to minus infinity. Then it jumps back here, but this was not marked as already explored to the left. So what it should happen is, and then we try it again, and again, and again, and again. But then what is this? Oh, let's just do it again, right? We come here, and then we mark this one as explored to the left, because we rediscovered this thing or something. Jumping to 11 with H direction is right. I wouldn't even care, man. This is not correct. We should immediately abort this. Because 11 was already explored to the right. Set last screen to 70. Yeah, this is wrong. This is wrong. So we go back here and then we go to the right, despite that this thing has been marked as already explored to the right, which is correct because I'm never looking at it. I just abort if they are explored to the left and the right. So what should happen is that we come here and then we should immediately abort, going to that side, and then therefore jump back to the same minimum again, and then we with going to the left, and then repeat that. I think somewhere in here must fix something. H direction is set to the opposite. Then we go to the base cubic, and then we handle this local stream jump. But no, because it is already handled in that direction. Note that if I do this and we go here, which is just this function, then I check if both directions have been explored, then I return false. So then this return false and blah blah. But I'm not checking. I probably should first check done. Yeah, wait a minute. I do have to enter here. I have to do the done check first. complicated. Yeah, nou ja, officially I would have to call this. I think I made a rule of that as well, so I wrote that in the description as well. So it says an abort happens when handle abort direction is called because we can no longer go further into a chosen direction. That happens. 1. You find a new local minimum which isn't better than the previous found. That's the main reason why we enter here. 2. The current local extreme was already explored in both directions. That's not a reason to call abort. Then we just return false. 3. We are going into a given direction. That direction was already explored. That's this the new rule. So then that is called. And then there's a point 4. There is only a single minimum, so we fail to choose which side to go into. I think I just pick a random side. So we would just run out of. Let's see. Or there is only a single minimum. Yeah, I don't know. I just pick a random side actually. In this case. In the histogram case, it has to skip that. But in this case, we just don't know. So we just try some direction. And then we run out of energy, and then we try the other side, and then also run out of energy, and then abort because both sides have been explored. Don't think I need that rule. Yeah, maybe I should add something. If you, I mean, in the end, it's for a neural network, so I'm not super interested in loss functions that go to minus infinity. It's just never going to happen, or you have a really big problem. On the other hand, it would be nice to at least throw an exception instead of running out of stack space, which would be the case now. This is now going to recursively call itself. Or not. We call it again. So this was called. That then calls this. That then calls itself again. And then we come here for the second time. This is still not true. Oh, then this is not true. So we continue. Okay, so no stack overflow. Okay, well, good. So we go to minus infinity again, and then when that turns, it's already in a loop. Yeah, nice. So we just keep trying. So this, we asked the user basically to give us the function value and the derivative at this point, but that is so far to the left with the exponentials and stuff. It was not calculatable. So we got not a number back. And then as a hack, I just abort that direction. Maybe I just should not abort the direction, but handle it as a minimum. Then this would be the final. I mean, the one before this or something. I don't know. Yeah, it fails, so we jump back to. I mean, I could do call abort. And then it jumps back to the best minimum, which is at minus 55.77, trying to go to the right. Which then immediately calls abort again. On minus 7,600 what? It looks like I didn't set W correctly. It was just not changed. That is what's going on here. That's also not good. Something is very wrong. So 24 is the smallest value that still was calculatable, and the range is set between minus infinity and that point. So it really wants to try again left of 24. And the local extreme that we had, that was the furthest in this direction, is that one, which has well, a local minimum at minus 490, which is kind of random, but okay. But that wasn't even far enough. Of course, we want to go left of that. And therefore, it's repeating the same value. I think it's just going here and then adding the scale size to it, which is all in the thousands. And then it just asks that again, because it never got a good point for it. And then it repeats. Hello, Tryon. Yep, okay, I think we're done for today. This silliness was fun. Maybe you should temporarily or permanently remove it, just to see it really finish. There's no finish possible going down here now. Yeah, let's see if we can repair that. So in this case we had a function this first cubic. No, I want to do this one. First local extreme, that doesn't sound like it here. Yep, this parabola here. Originally, so I don't want to use the TP2 and the sigmoid 2 anymore. I should have left the old function here because I have no idea what it was. What? Okay, 2 lines in. Let's comment this one out, and then we remove sigmoid 2. As in, we set sigmoid 2 to 1, I suppose. Yeah, so this becomes 0. Times something is nothing. And this is 1, so we can remove it. That should be it. Should be the old function. And then of course I don't have to pass sigmoid 2. String. Now it finds this one first, and then we go to the right, then we find that one, and then we go further to the right, we find that one, and then we jump back here and go to the left. Therefore we find that one very quickly, go further to the left, and now we find very slowly, I have to fix that cell, that one. And now we go still to the left, so we go up again until we use more energy than we have. Assertion, it did finish. But Tessut wasn't happy because success was not given. Now, why is that not possible? Oh, now I see what the problem is. Line 666. You just have to make an empty line there. Maybe jump over the go-to. I'm just going to break there and see what the problem now. Yeah, why not? Break 666. Step. state was never set to success. How lame is that? Yeah, I forgot to do that. Well, it's a bug. Algorithm.cxx at line 903. Ridiculously slow. Success! Ta-da! Global minimum. Fuck me. No! No! That is not the global minimum. What are you talking about? Probably the success was set where I set the global minimum. Oh, you gotta be kidding me, right? I can never go to bed like this. Or just, if success is set, then we are allowed to call minimum. That returns cubic used. What? No, that's just nonsense. It should be best minimum. Oh yes, that's the thing. That's the thing. So you see, set global minimum. That's what it should call. No, finish. I should call finish. That gets one more sample and then calls set global minimums. Yeah, I didn't know how to finish this. Well, you call finish. Even this is called finish. Yeah, you have to call finish. Okay, so what was the last change that I made? So also this file in the neighborhood of 666. I thought. No, it wasn't. Something with state is success. Yeah, here. So you have to call finish. And then return true or false. Good question. I think return true. So this happens from a call to handle local extreme. Not that one. No, it's after a call to abort. See? Yeah, yeah. So I should return true here, otherwise we return false. That would be a hard abort. We don't want that. We just want this break here. And then what happens? Then we get here. Chain find larger. It just gets one more sample, I suppose. Just pretend everything is okay. Yeah, let's try that. Probably do, and then turn true. Success. Global minimum is minus 122 at minus 122. That is so not true. Oh, that's that one more sample, of course. That's the one more sample. No. No. What? Yeah, no. That one more sample was the idea of that was that we're already in a minimum, and then just I want to keep going for that same minimum. So just, you know, actually ask for the value of the jump to the last minimum, to the extreme of the last cubic. I suppose I have to set W, because I bet then this is the last value, and it's just the last value. That's it. So it was all nice and dandy, but now what I want to do is also set the W value. Which you can't do here. I mean, I have to invent another function. I made it impossible for myself to change the W. The painful truth. Chess becomes very, very tempting. I found a public function which I'm going to abuse. No jump step 0. Oh no, I want to do an extreme jump. I could just call that as private. Don't have it. We just don't have it. This is the one that I really want. This is exactly what I want. And now with a step of 0. Yeah, this adds scale. I can't call that one. And the last extreme plus step, so without step. Just have to add a new function here. I'm just getting too late. I want to go to bed. That is, I definitely stop now with this coding. It's not going to bed, of course. You know me. Undo, redo, I don't know. Fix me. So, doesn't compile. I discovered a new AI called Claude. Everyone already knows it, of course. Claude.ai. And it's better than GPT. Just is. Yeah, look. Whoa, they cheat. So I asked the same question to all the AIs that I have here in the tabs. And none could even come close to an answer. I mean, they just put nonsense. This is also wrong, the first answer. But it is surprisingly... I mean, it's actually doing Boolean logic. It's what it says makes sense, unlike the other AIs, which are just starting to babble. But the answer is incorrect. And then I said, no, it's a 10, but incorrect. Try harder to be correct. And I got it. I mean, what the fuck? Really? Better than ChatGPT. Then I said, excellent. I'm impressed because all other AIs that I tried failed to find this. So then I thought, let's ask another question, this time about mathematics. So I said, I'm a C++ coder involved in mathematics, blah, 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 blah. Here's the first challenge. Consider a cubic equation and give a as simplified as possible expression for the value of its inflection point. I mean, write a program that can answer this. Huh? You start to look like a real AI if they take this sentence and then come with something useful. Well, he knows what a cubic is. He knows what the inflection point is. He knows how to determine the thing. The calculations are correct. And the answer is correct. The only thing that was, well, not perfect is that I said I would prefer to have it, the answer in the form b times something plus d. That's all I said. And bang, it comes with this, which is good enough. Just, yeah, perfect. Claude all the way, man. And then I thought, if I ask ChatGPT something about my debugging library, which has existed for more than 20 years, C++ debugging library, libcwd, then it's kind of like, yeah, I wouldn't know if you want to use that. I think it heard of it, but it was very... Only after I said, hey, I'm the author, it became more positive, but yeah. So I think I'm going to ask that. And, well, it came up with something that probably wouldn't work, but it didn't talk it down, didn't do negative. This probably just works, except for that you have to start with include sys.h. And let's see, yeah, there's no CMake here. So then I said you must include sys.h, and main must look like that. And then we got the perfect case. Yeah, this is how you do it. And then I said, oh yeah, and it immediately, I didn't even talk about CMake, but it immediately added some CMake shit that wouldn't work. So a few things are missing, and you need... No, actually it is correct in this case. Yeah. Okay, well, I must say then I went into detail. I just spelled out how to do it, because I thought maybe it will learn from it. So then the CMake thing became this. This is how you use the shortest version to use libcwd. Pretty cool. And then we had this interesting conversation. So we have one faculty, so 1 factorial times 2 factorial times 3 factorial all the way till 1000 factorial equals a factorial squared times b to the power 3 times c to the power 4. At first it said, well, you can't say much about it because the number is so big that you can't even calculate it. Then I said, there is more you can say about it. For example, it is easy, between quotes, to establish an upper bound on a. Try to deduce what is the largest possible value of a. And then it came up with some stupid shit saying that a must be less than 1000. In fact, it called 1000 a prime factor. So I said 1000 is not a prime. And then it came with the largest possible value of a is 996, which is correct. That's all already more or less impressive. Now I didn't have all the reasoning that is necessary for it, but okay. And then I tested what happens if you disagree with it, and unfortunately that's the same as all the other AIs. It tries to please you. So I said the upper bound on A is in fact 997, not 996. And then I ask it a question from which it can deduce that 997 does not work. So I ask how many times does the prime p, when p is between 500 and 1000, occur in the product of factorials? And then you get the common shit again. You're absolutely right and I apologize for the error. Thank you for the correction. Indeed, the upper bound is 997, not 996. Yeah, so again, shit. That's too bad. But the other question, it did answer correctly. So it found that the number of times that p occurs is 1001 minus the prime. So for 997, it occurs 4 times. Now, of course, it's easy to understand that therefore 997 does not work for A, because then you have 997 twice in the square here, and you can't put it twice in here. You can only put it 3 times or 4 times in it. But okay, so I said it's excellent that he had it that it occurs 4 times. And then I explain why 997 does not work. And it said, yeah, well, unfortunately, you believed I was right on face value when it set upper bound with 997. The user is not always right, blah, blah, blah. Yeah, okay. But still, you know, a nice summarization of my explanation. And also said, you're absolutely right, they should not have accepted your statement. Hopefully it will actually learn from this kind of conversations. Right, that about Claude. Let's play a game of chess, as usual. I'm gonna win this with e4. Tech. Let's go for fast center occupation. You know, why would I not go here? Put the queen in the center, man. No, more center, or shall I develop my bishop? No, I'll wait with the bishop until that knight attacks my queen. Do I want to pass this point? No, because then my bishop can't go there anymore. I should probably just develop this. The knight is not doing anything. I can pin it, but that won't help me much. This is a nice move. Put a bishop there. Take my queen. Take my queen now. Take it. Cautious guy. Yeah, I think he saw it. He's not going to do this until I can't pin it anymore. That's nasty. Okay, I'm gonna go here then. And here. And here. No, my queen is going to be chased away. So I go here and then I can't really attack it. Could attack it from here. Like, so maybe I should move this pawn up one. Yeah, maybe. So now we can go here. Okay. Not going to move my bad bishop twice. Give away a piece. Move the knight and then put my queen here. Threatens mate on 2 squares. Can he defend that? Plus I have this bishop like that. I can't calculate it. I'm just going to try it. I'll probably give the game away here, but on the other hand, maybe he believes my bluff. Steven. He believes my bluff, okay. Is now threatening to take it? Not sure about that. Could still give it away though. Take my knight. I just want the open file here, man. Let's sacrifice a full piece for that. We can sacrifice a full piece for that. Okay, this starts to be nasty now because my rook is attacked and then maybe then he takes it. Nah, it's not much different, so just go away with the rook. And he's gonna give check. No, it's not going to give check. It's kind of amazing. And I win a knight. No, not really, but it's still looking very juicy. Oh, needs the castle. Yeah, he found it. So I go away and then the knight goes there, maybe. Yes. Let's attack that bishop again, because why not? Started thinking about sacrificing 2 pieces now. Oh, he wants to go there. Nasty. It doesn't matter, I just go here. So I take here, he takes. I take there with check, he takes. I take. I have 2 knights less. But maybe it's worth it. Let's first develop this piece though. Sacrificing 2 pieces maybe a little bit too much until you have it 100% fully prepared. I really want to get rid of this knight. Let's just sacrifice it here and then push this pawn. What's she gonna do? Oh, no, yeah, no, then he takes my knight. My queen should probably go here first as well. What am I gonna get? I'm going to gotta check here. Well, I don't care. And I go here. I see no problem. Now we can start sacrificing. I just know it. I know it. I'm just going to do it. That knight is just in the way. Come on. Come on. In between check. Nobody knows why. Yeah, the why not move. And there's my open file. How beautiful is that? I think it was totally worth the sacrifice. Don't have time left though. Yeah. Why not? It's with an attack on the queen. Well, no, I closed this file. I don't know. Maybe I should have taken with the bishop. Yeah, that was probably better. I'm blocking my own bishop now. This is not good. But the queen, where can the queen go? I mean, I have this square, I have this square, this square, this square, I have all the fucking squares. The world is mine. It's made in 1 or 2 or something. No, it's made in 1 here, no? Made in 2. Made in, I don't know. I don't know if it is made at all, actually. Come on, I must go mate, because I have only 29 seconds left. Where's the mate? That was actually not too bad. And now he lets the clock run out. Demotivated as Steven is. Couldn't find the phone anymore. Okay, I did win. I'm going to bed. I think that was a nice sacrifice. Yeah. How lost do you think I have been? -5? Still have to check that. I probably was very bad somewhere. What is better? And the queen can then be in the center. Still positive. Okay, that wasn't the best move, but oh, -2. -2, -2, -2.5, -2 point something. Oh. Ah, totally possible. Totally possible. -1, -3. And he even did that. -3.5. Almost 4. The check was nonsense. Still -3.5. That was a bad move, but still -2. Oh, the so I'm just going back here. Now I have a draw again. Now I'm better again. And yes, that sacrifice was wrong. The other sacrifice was correct. Plus. So this was a wrong sacrifice, but after this check, there is no. It's actually a good sacrifice. +3, +6. Okay. +10. I even saw that. Made in 12. That wasn't a bad move, apparently. Made in 18. I missed the mate in 18. Damn it. Only +5. We're back at mate in 13. So, yeah. And this? Bad. But I had to defend this pawn. And he did give it away. Mate in 6. So not too bad. At some point it was -3 or something. But it's it. Yeah. So this was a bad move. He should have done the bishop move now, and then I go here, and then he did that too, but at a different moment. Yeah, now I don't have this square, so I can't chase the knight. Because this is just a bad move. -4. But. Oh, sorry, you can't go here. Yeah, I do have tick tonight. Do we have ticks here? And then I have to tick back with that one. Oh, this thing is pinned. Oh, yep. He's going after my king. King runs away. Threatens a queen exchange. I stop that. Now the knight can go away. Check. Knight goes back. What the fuck? Breakthrough in the center with me not castled. No, let's do what the computer says. Sacrifice. I probably just had nothing here. I just had nothing. Let's keep that file closed. Yeah, I just don't have an attack. Everything is blocked. Pawns are completely in the way. Very nice that I have an open file here. Not. I hate computers. They never give you a chance. Good night.